Greetings from the year 2022. My name is Rickson, and these are the chronicles of my mission to save humanity from the deadly pandemic of deadliness. This week, I'll be working on extracting power from the Tesseract in order to charge my communicator. There's no one to communicate with, but I just really want to play Flappy Bird. I'll start by trying to desolder these USB ports from this ancient hub device. I had some difficulty desoldering the shield, and I knew I'd have a problem getting these legs through the board, so I bent them aside instead. To secure the port mechanically to the board, I decided to strap these little flaps down with semi-rigid sections of wire. After connecting the power leads from the Tesseract and checking all the connections, I now have two unified Sirius BAMF ports to power my time travel devices. There is still one small problem, though. A standard port can supply only a limited amount of current. Since this one is connected to the Tesseract, it can supply quite a bit more, but it needs to signal the device that it's safe to draw more current. What I'm going to do is connect together the data pins of the port. This lets the device know that it can draw up to about 2.4 amps from the Tesseract, and I'll get a faster charge. However, when I connect a somewhat newer device, this one still does not go into its fast charging mode. Why is that? Well, it's time we talked about the power. The power is equal to voltage times current. So in this case, the power is 5 times 2.4. which is 12 watts. This communicator can charge at 18 watts, which would require 3.6 amps, but that isn't how we do it. First of all, 2.4 amps is already quite a lot, and if you try to draw too much current through a wire or terminal, it can cause it to heat up. Obviously, that can get pretty dangerous, and even start fires. What we need to do is increase the voltage. At 9 volts, we could get 18 watts with only 2 amps, which is exactly what this device tries to do, but this is where it gets complicated. The device can't just draw more voltage. It has to signal the port to send voltages. By default, the port has to stay at 5 volts, since that's the standard, and only switch to a higher voltage when signaled by the device. While it's perfectly possible to do this, the electronics required are pretty complicated with only 4 channels in the connector. And to make matters worse, we're already sacrificing the data channels to get higher current. There just isn't a simple way to request more voltage. If I switch to a USB-C type connector, which this device is actually designed to use, this connector has many more channels than just 4, and signaling for different supply voltages is already part of the standard for this connector. However, since I have neither the ports required nor the desire to build the signaling logic, I'm just going to make do with the slower charging rate. For the main time drive, however, I will have to use a higher voltage, so next week I'll go into some methods for converting voltage levels. If anyone knows what voltage a time machine runs at, leave me a comment.